You are not audible. You can reply in chat. Okay, so I'm gonna give you some questions. There is power cut off, so I'll be switching on the video soon. So first we are going into this question. Please start doing this. Is there any answer for the question number 23 to 25? 20 to 25. Very good. Please send the answer in chat box. Not sure about 25. Oh, 25, if you are going to say this is your Rimmel-Tillman reaction. I told you that in Rimmel-Tillman reaction, the intermediate, attacking intermediate is your dichlorocarbon. And which is dichlorocarbon? I wrote it like this, CCl2, and there is 2 electrons free. So this is your dichlorocarbon. Please do the rest. Very good, Austin. All the answers are correct. Let me know the answer of 26. Very good. Go for 30, 31. Very good, Austin. Go for the next. Just wait a minute, Austin. Let me check the power. Very good. Go for the next. Yeah, 37, I'll explain. Are you done with 38? 38. Which one of the following is most acidic? Very good. C. What did you tell about 36? Now see. For 37, it's very easy. Oh, phenol with zinc dust. In the last class, we studied reaction of zinc with reaction of phenol with zinc. Okay. So this will reduce this zinc and you will get directly benzene. After this, you are going to use CH3Cl in the presence of anhydride AlCl. This reagent is your Friedel-Crafts alkylation, FC alkylation. That means there will be generation of that means there will be generation of an electrophile that is CH3 plus and it will attack on this. That means you will get toluene or methyl benzene. After this, you are going to react this with alkaline chaminophore. That means basically this will be directly converted into carboxylate anion, which will be again going to react with acid. So it will give benzoic acid. So the answer will be B. I think it's clear to us. No, clear to you. Question number 40, 41, any answer? Did only one way. Oh, 40 is wrong answer. 40 is C. See the correct order of acidic strength for the following. The most acidic will be, okay, just wait a minute, please. The correct order of acidic strength for the following. No, no, it's correct. You told me the correct answer. 48, you said, oh, very good. 41. Actually, 40. Yeah, it is C. Why are you not sure? The ionization constant of phenol is higher than that of ethanol. You know that. If ionization constant Ka acidic constant is greater than Ka1 is greater than Ka2 only because this is more acidic, this is less acidic. Or you can say conjugate base of A1 will be equal to greater than stability of conjugate base of first will be greater than stability of conjugate base of second. So phenoxide ion is bulkier than this is wrong. Phenoxide ion is a stronger base than ethoxide, phenoxide, and is stabilized through delocalization. This is more correct. Okay. So in the last class, we did the preparation of this ether from one method. Now we are going from the next, which is a named reaction, that is Williamson synthesis. Williamson synthesis. Now see Williamson synthesis. Very simple. When you are going to react an alkyl halide with an alkoxide or phenoxide, okay, that means basically alcohol. In alcohol, H is replaced by any metal, that is alkoxide or phenoxide. So what will happen? You know that this is having positive charge, this is having negative charge. Now just wait a minute. We're going to differentiate between this is positive, this is negative, this is negative, this is positive. So this negative will be attacking this and this will be going with this. So you will be getting ROR and NaX will be eliminated. Very important concept in this, because here the degree of alkyl halide will matter a lot. Okay. So if you have 3 degree, 2 degree or 1 degree this, that is all right. But if you are going to have 1 degree this, that is cool. 2 degree this, that is cool. But 3 degree is not cool. Basically, elimination will be this. I'll show you the reaction. Okay, and this is Williamson synthesis. So if you have 3 degree alkoxide, you can see this is the scenario. 3 degree alcohol it was and reacted with this. So it will be converted into this. Now, when you are going to react this with primary alkyl halide, you know what is the mechanism? Very simple, negative, positive. Okay, so this will be attacking on this and this is positive. So this will be going with this. So what you will get is basically CH3C, CH3, CH3, and then O, and then again CH3. So this is how the preparation of ether will take place. If you want to name it, very simple it is 1, 2, 3. So 2-methoxy, 2-methyl propane. After this, but if you have tertiary alkyl halide, then elimination competes over substitution. So first write it, then I will give you another example. This is with 2 degree also not cool. If you want to prepare alkyl halide, sorry, it's from alkyl halide and alkyl alkoxide. So this should be 1 degree, 2 degree or 3 degree elimination will take. So you can get the right if the alkyl halide is primary, then ethyl. If it is secondary or tertiary alkyl halide, then elimination completes over substitution. We get alkene. So very simple it is. If you are going to have this, yeah, you are going to react with this, then what will happen is very simple. First of all, Br and hydrogen, one of the hydrogen will be eliminated. Let's say CH2 is this and hydrogen is this. So this will also be eliminated and you will be getting CH3. CCH3, CH2, WC. This hydrogen is going to react with this and you will be getting CH3OH. Okay. And this Na and Br is going to connect with each other and form a solid. I think it's very easy to understand, right? It's because alkoxides are not only nucleophiles, but also a strong basis. Let me know when you are done. Very good. So what about phenols? Basically, phenol also would react in the same manner. One of the reaction we already did while doing the acidity. This is your phenol, and if it is going to react with sodium hydroxide, you know, phenoxide ion will form O negative, Na positive. And when you are going to react this with Rx, you know, substitution will take place. This will be negative, this will be positive. So this positive will be going here, and you will be getting this. And as a byproduct, NX. And here as a byproduct, you will get H2O. Is that clear? Write it. After this, we are going to see the chemical reaction. And in chemical reaction, first we are going to talk about cleavage of CO bond in ethers. How it takes place. Are you done with this? Cleavage of CO bond, we already know. If you are going to react this with hydrogen halides, HX, you know what will form. Very simple it is. Plus minus you can play. So alcohol and alkyl halide will form ROH plus RX. If you are going to, again, if you have HX in excess, then what will form you can see is very simple. Negative, positive, positive, negative. So this is what you will get. Rx plus H2. So basically, if you have hydrogen halide in excess, you will directly get this RX. In the same manner that phenol is also working, if you have this phenol, not phenol basically, with benzene ring, this methoxy or alkoxy benzene, if you are getting, so HX is there. So negative, positive you can play and you will get phenol along with the formation of alkyl halide RX. Very simple it is. Or if you have asymmetrical ether, then it's also good. You can see RO dash is there. Mixture of things you will get. With this, you can get RX, depending upon which you are going to cleave the bond, negative, positive, and then you will get R dash OH as well. If you are going to break this bond, you will be getting R dash OH and RX. So if you are going for reactivity order is very important. The order of reactivity of hydrogen halides. Hydrogen halides. Yes. HI, then comes your HBr, then comes your HCl. And the cleavage of ether. Takes place with concentrated HI or HBr at high temperatures. At high temperatures. So very simple it is. You can do this. Are you done with this? Okay, take your time, not a problem. Now, if this goes with alcohol or this goes with X alkyl halide, which type of alkyl halide forms. That depends upon the degree of this. If this is your tertiary, then halide will go with this. X will go with this. If this is tertiary, halide will go with this. For that, I'm going to write a point and give you an example. When one of the alkyl group is tertiary, when one of the alkyl group is tertiary, the halide formed is tertiary. Why it is so? Because carbocation forms, and the one which is more the carbocation which is more stable, the halide formed is tertiary. The carbocation which is more stable will go with X minus. If you are going to have R and R, one is 1 degree, one is 2 degree. So 2 degree will form carbocation because in that it is more. Let's say this is the scenario CCO CH3. Then CH3 is there, and then CH3 is there. And when you are going to relate this with hydrogen iodide, what will form? So basically, this will be cleaved in negative, this is positive. Because carbocation, tertiary carbocation is more stable. If you are going to cleave this, and you know this is not stable, so you are going to do this. And accordingly, you can use this negative, positive, and you will be getting tertiary halide. You will be getting tertiary halide, and here you will get CH3OH. Is that clear? So I can show you the mechanism in two steps. This is the scenario. CH3, CCH3, and CH3 is there. You know that there is acid, H plus is there. So oxygen will be bonding with hydrogen. And there is CH3. Okay. Oxygen has positive charge, which means less stable. This step is slow. And what will happen in order to get a stability, oxygen will take electrons from carbon. Oxygen cannot take electron from methyl on the left hand side because it will be highly unstable, so it won't give. And this becomes CH3OH. And then after formation of carbocation, you can see that I minus left in the reaction. So negative, positive attract each other. So it will be like this. This step will be fast. And you will be getting this CH3C. I is there. And then it is CH3. And then it is again CH3. Let me know when you are done. Let me know when you're done. After this, we have again the electrophilic substitution reaction. And I think you can do this by yourself. I'll just write the name. So first of all, we are going for halogenation. Methoxybenzene is there. Br2 in presence of ethanoic acid. This is a common name, that is anisole. The name of the product in terms of anisole. Let me know when we are done with this. See, if you are going to do with this reagent, you will be getting an electrophile Br, and Br will be attacking at two places only because OCH3 is plus M, that means meta and ortho and para directing. So OCH3 with respect to this, you will be getting Br joined at ortho and Br going to join at para. So this has a name, para bromoanisole. You can write anisole, or you can write ortho bromoanisole. Is that clear? Okay. Let me know when you are done with this. Are you done with this? After this, in the next we have Friedel-Crafts reactions. So when we are going to talk about Friedel-Crafts reaction, there are two types of reactions: Friedel-Crafts alkylation and acylation. So alkylation, that means alkyl halide you are going to use CH3Cl in the presence of anhydride AlCl3. Wait a minute. Anhydride AlCl3 in the presence of carbon disulfide. And there is another Friedel-Crafts acylation, which you are going to react this with acyl halide in the presence of same thing, anhydride AlCl3. Please write the product. Can you do this? Okay, do it. Match the answer. There will be generation of an electrophile, carbocation, and this will be attacking OCS3 at ortho, and then it can attack since OCS3 is a plus M group, so it will be ortho and para direction. Which one is more stable? This is your major and this is your minor. What is the name of this? So we can write 2-methoxy anisole, 1 and then 2-methoxy anisole. And what its name? 4-methoxy anisole. No, not anisole. Since I took methoxy, it will be toluene. 2-methoxy toluene. And here it will be 4-methoxy. With respect to an toluene I am talking, so it will be like this common. Now for this, there will be generation of an electrophile. So this C plus will be attacking either at ortho. That means this will be the scenario, COCS3, or either at para. So this will be the scenario. You know which one is more stable, major, and which one is minor. So it will be something like this. So this is your major, and this is your minor. After this, if you are going to write the name, it will be 2-methoxy acetophenol. Acetophenol is the common name. Acetophenol. And this will be 4-methoxy acetophenol. Let me know in order. Very good. The third and last one for this topic is your nitration. These reactions again and again, repeating. So you are going to use HNO3 on this anisole. In the presence of H2SO4, you can see H2SO4 is there, HNO3 is there. So I think you can write the product, right? So OCH3 is a which group? Plus M, so it is ortho and para-diactic. So this is 2-nitro anisole, and this is 4-nitro anisole. So this will be your major, and this will be your minor. So let me know when you are done with this. Very good. Please do that. Any answer? Austin. Okay, okay. No problem. No problem. Very good. 54A. That's a good answer. Very good. Not C. Identify Z in the reaction first, as we are in the presence of H2O2, is your anti-Marconi group. That means negative part will go to that carbon which has greater number of hydrogen, and positive to that carbon which has lesser number of hydrogen. So basically, this is what you will get: CH2, CH2Br. After this, you are going to react with CH3, CH2, Br, sorry, ONA, ONA. So very simple it is. Negative, positive, negative. Oh, wait a minute. We need to prepare. This is your, what do we say? Negative, positive, negative, positive. So 4 carbon here, 1, 2, 3, 4. Then oxygen, and then 2 carbon. So what you will get, I think D. How many carbon is there? Just wait a minute. 1, 2. No, no, this will not be. CH3 is here.